Hi guys, how's it going? I decided to do my fluids project on superfluidity, which is basically a phenomenon that occurs that causes a fluid to lose all sense of friction. It means it has no viscosity and it has infinite thermal conductivity. And this is a super interesting because all of a sudden you don't have any losses due to friction and all sorts of wacky things start to happen. Basically, this was a phenomenon that was discovered, I believe, in the 1930s by some scientists, first with helium-4, and later with helium-3 and a variety of other elements. But it's perfect for helium-4 because it stays liquid and this starts to occur right around 2 degrees Kelvin. The other elements you have to get quite a bit cooler. Um, so helium becomes a liquid right around 4 Kelvin, and then if you continue to cool it down to about 2, it enters this superfluid state where, yeah, there's no viscosity, no friction. And some of the things that can start to happen is it will creep up walls, basically looking like it's defying gravity. It can also seep through vessels, whether it's a beaker or whatever container it's in, that don't seem to have any holes in them. And it's interesting because for a while we didn't quite understand why this was happening because it can't be described or explained by classical physics. You really need to delve into quantum physics and the quantum realm to understand this. A lot of it has to do with interactions between bosons and fermions, which are subatomic particles, um, and they just interact in a super interesting way when you get it in the right state. Um, yeah, so basically, these atoms lose their individual identities and start behaving as a single quantum entity, and that's how they flow without friction. One another interesting aspect of superfluid helium is its ability to exhibit quantized vortices, which are basically just tiny little whirlpools that continue indefinitely. They don't stop, they don't slow down, and that's just because of the lack of friction. Um, but also can only occur at discrete values. And the math behind this, I was struggling to find it, but it's described by the quantum of circulation, which is basically k equals h over m, where h is the Planck constant and m is the mass of a helium atom. Um, yeah, I just thought this was a super cool concept I had never had exposure to. I would have loved to have gotten my hands on some super cool helium to show you guys, but if you ever get the chance, go for it.